Blue.
Right. So what did you do in your brain? How did you assign it to blue?
I just like see the because we have on the middle of red. I mean, on the left or right side of the black circle, there's a blue color.
Hmm.
So I think about the relationship between the black and the blue circles in the middle,
Hmm.
and the black circle is like nearest to the blue ones.
So algorithmically, what your brain just did, it took distance from every point to the question test point. Our test point is the test point, the black point, and we took the distance from all the points, and then we said, okay, let's look at k nearest neighbors. If k is 3, then these are the nearest neighbors. If we 3 is k, then we will say the black point is red because more neighbors are red than blue. But if we take, let's say, 5 nearest points, in that case, 5 nearest points will be these 5. In this case, we will assign it to blue class. Does it make sense?
Yes, Professor.
Very intuitive, right? K nearest neighbors algorithm takes distances from all the data points and then rank them, pick top K. Looking at those, if K is 5, we will say visually we can see these 5 are the nearest ones. So we will count how many blue, how many red, and that voting will give us the decision. More blue, so this black point is blue. Now you can imagine if the K value is 3, in that case, our decision is different. So that means the value of K is going to change our results. So KNN classification is sensitive to the value of K. Second important thing is that this distance taking, it's not, it's very expensive operation. If you have millions of data points, for every test data point, you are calculating million distances, which is going to cause some delay. It's a lazy model. Actually, it is model-free technique. We don't model our data in regression, logistic regression, neural network, the decision tree. We construct a model of the data and use that model to predict the test point. But here we are not doing that modeling. We are model-free. We are just taking the distances. Based on the distances, we decide among k nearest neighbors, the who is the majority. Majority takes all. That's the concept. It's easy, right? Very interesting, but with its own downsides. From your imagination, can you say that you can discover nonlinear, you can do nonlinear classification with this technique? By linear, we mean that the class boundary is, it looks like a line, but in here you can see, depending on k, the class boundary is different. If k is 3, then it is different boundary. If it is 5, different boundary. 7, even different boundary, right? So the KNN is a nonlinear classification algorithm. It can do nonlinear, so it should be better compared to linear algorithms.